Okay, now we will see matrix inverse. So how can we find the inverse of a matrix? In your last semester mathematics class, you might have studied about finding the inverse of a matrix, isn't it? So we will see how to find the inverse of a matrix in MATLAB. Okay. So this is a simple example. Okay. First of all, you need to enter the matrix. So input, you can enter the matrix. Okay, so A will be your matrix. So you can enter A as a matrix while executing. Okay, so input, enter the matrix. Next, in order to find out the inverse, you need to check two conditions for finding out the inverse. First of all, the inverse of a matrix A exists only if the matrix is a single non-singular matrix and if the matrix is square matrix. So two conditions need to get satisfied. Only if the matrix is a square matrix and also the matrix needs to be non-singular matrix. So first of all, we will check whether it is a matrix is square matrix and then we will check whether it is a non-singular matrix. So first we will check whether a matrix is square. Okay, how can you check whether the matrix is square? You know the function size. What is size? Size is an inbuilt function used to find out the size of an array or of a matrix, isn't it? So size of A is a matrix. So size of A will give you the row, how many rows will be there and how many columns will be there. So it will return the size function will return the number of rows and the number of columns. So M will be the number of rows and N will be the number of columns, isn't it? So M will be the number of rows and N will be the number of columns. So now you got the number of rows and number of columns. Now how can you check whether it is a square matrix? If you want to check whether it is a square matrix, you can check just by checking if M equal to N, whether the number of rows equal to number of columns, whether the number of rows equal to the number of columns. You can check that whether M equal to N. Okay, suppose if M equal to N, then you can proceed. Now you want to check the next condition is whether the matrix is non-singular or singular. Okay, how can you check whether the matrix is a non-singular? Suppose if the determinant of A equal to 0, the determinant, how can you find the determinant of a matrix? Just type DET. DET is an inbuilt function. DET is an inbuilt function. So this DET of A will return you the determinant of A. You know how to calculate the determinant of a matrix manually, isn't it? In MATLAB, you can find out the determinant of a matrix using the function DET. So if the DET or determinant of A equal to 0 means the matrix is a singular matrix. Okay, so if the determinant of A equal to 0 means you already have studied all this. If determinant of A is 0 means the matrix is a singular matrix. So for a singular matrix, the matrix inverse does not exist. For a singular matrix, the matrix inverse does not exist. So you can display this inverse doesn't exist. So you can display this, but the inverse does not exist. I hope this is clear. So you can just display that the inverse does not exist if determinant equal to 0. The matrix will be a singular. Our condition is the matrix should be non-singular matrix. And else, that means if the determinant is not 0, else means the determinant of A is not equal to 0. Then we can compute the matrix of A. Sorry, we can compute the inverse of matrix A. So how can you compute the inverse? You can have the inbuilt function INV. So INV function is used for computing the inverse of a matrix A. So INV is a very important function. INV of A means the inverse of A. And I am defining or assigning to a variable INV underscore A. You can assign your own variable. You can keep your own variable. INV is an inbuilt function. INV of A means it will find the inverse of matrix A and you are assigning it to a variable INV A. Okay. Now you display the inverse is. The inverse is disp INV of A. Okay, so you will get the answer as INV of A, that is the inverse of matrix A. Okay, now end. This if else statement you have ended it. this if else statement you have ended it. Okay, that means if determinant of A equal to 0, if determinant of A not equal to 0. So that if else statement you have ended here. Okay, now there is another else. So if m equal to n means it is a square matrix. M is the number of rows, n is the number of columns. Number of rows equal to number of columns means it is a square matrix. Okay, so if this is the else part. So what is the else part? If m not equal to n. This is the else part. And what is the else part? If m not equal to n. That means the matrix is not a square matrix. So you cannot compute the inverse of the matrix. So display matrix is not a square matrix. So if else part means if m not equal to n, you can display the matrix is not a square matrix. And then finally the end of if loop or if statement. Okay, finally the end of if statement. Okay, so I think that is clear. It's a very simple program. This is a generalized program. You need to write, you need to find out the inverse of a matrix like this. This is a very generalized program. Okay. Shall I run this? Enter the matrix. You can enter the matrix as 0, 1, 2, then a colon, semicolon. Semicolon, why you are putting a semicolon? To separate the rows. So this is the first row. Second row is 1, 2, 3. The third row is 3, 1, 1. Okay, so this is my matrix. So my matrix is 0, 1, 2, 0, 1, 2, 1, 2, 3, 3, 1, 1. That is my matrix. Here it is displaying the inverse. See, the inverse is this particular matrix. So the inverse is also a matrix, so that you can compute the inverse of a matrix like this. I hope this is clear. Okay. Now you need to understand some. You have already dealt with solving system of linear equations. So I will show you how to solve a system of linear equations in MATLAB using matrix method. Okay. So before that, I want to convey you something. Okay. So A forward and backward slash or backslash. Okay. So forward slash is this slash. A slash B or A by B. Okay, is same as A into inverse of B. Please understand that A by B. This is the forward slash. Okay, forward slash A by B is same as A into inverse of B. Please understand that. And A backslash, there is a backslash operator. A backslash B is same as inverse of A into B. Both are different. Okay, A by B or A forward slash B is same as A into inverse of B. Okay, A by B, that means A backward slash B is same as inverse of A into B. Both are different. So please understand these two operators in MATLAB. A forward slash B and this is the backslash operator. Okay. So please understand where A is a matrix, B is another matrix. Okay. So please understand that this is not an element to element division. A by B, how can you compute A by B? Is actually you are computing A into inverse of B, isn't it? A into inverse of B. That is actually A by B. So this, please note that this is the real matrix division, A by B, or A into inverse of B. The real matrix division, not element to element division, not element by element division. Okay. For element by element division, you need to insert a dot operator here. A dot slash B. Okay, this is not element by element. This is the real matrix division. So please understand that. Okay. Now, okay, now I want to convey system of linear equations. Okay. So we are going to introduce system of linear equations. So solution of matrix equation. All of you have heard about this matrix equation. Ax is equal to B format. Okay. Ax is equal to B, where A is a matrix. Okay. A is a square matrix. A is a matrix or square matrix. Then B is the n rows, one column. B has only one column. It is a column vector. Okay. B has only one column matrix. It is a B is a column vector or one column matrix. Okay, A is an n cross n matrix. B is a n cross 1 matrix or n row 1 column matrix. So A is a n cross n matrix or n by n matrix. B is a n by 1 matrix or B is a column vector. Column vector, what do you mean by column vector? One column. I think, hope you understood this. Ax is equal to B, that is the matrix equation, and you need to solve this matrix equation. Ax is equal to B. Okay, now x is the unknown. Here x is the unknown. So you need to solve this equation means you need to find the value of the unknown, isn't it? You need to solve this equation means you need to find out the value of unknown. So here what is the unknown? X is the unknown. Okay, so A in pre-multiply A inverse on LHS as well as RHS. On LHS and RHS, you pre-multiply with A inverse. Okay, what is A inverse? A raised to minus 1. A inverse is A raised to minus 1. So you pre-multiply, not post-multiply, you pre-multiply A inverse. So here, A inverse into AX equal to, you pre-multiply this RHS also. So A inverse into B. Okay, now what you will be getting? A inverse into A. What is A into A inverse or A inverse into A? A inverse into A, you know that it is I matrix. What is I? Unit matrix. Isn't it? Unit matrix is I. So A inverse into A is I. I into X is equal to A inverse into B. So how can you compute X? X is the unknown value. So what is X? X is equal to A inverse into B. I hope this is clear. Okay, so you pre-multiply with A inverse. So you will get A inverse into A, that is Ix is equal to A inverse into B. So what is the unknown here? Unknown is X. What is X? X is equal to A inverse into B. That is the solution of this matrix equation. So what is the solution of this matrix equation? Ax is equal to B, A inverse into B. Okay, let me show you one example. 2x minus y plus 3z equal to 5. That's the first equation. Second equation is 4x plus 5z equal to 12. That is the second equation. Third equation is x plus y plus 2z equal to minus 3. These are a three set of equation, and you need to find out the value of x, y and z. Here there are three unknowns. There are three unknowns. Which are the unknowns? X, y and z are the three unknowns. Okay, so you need to find out the value of x, y and z which satisfy these three equations. That is a solution of this equation. So using matrix equation Ax is equal to B, you can solve this. What is A? A is a matrix. You know that A is a matrix. So what is A? 2 minus 1, 3. That is the first row. What will be the second row of A matrix? 4. Then y part is absent here. So 4, 0, 5. That is the second row. And what is the third row? Third row will be 1, 1, 2. That is the third row. So first row will be 2 minus 1, 3. Second row will be 4, 0, 5. Third row will be 1, 1, 2. I hope this is clear. That is the A matrix. Now what is B matrix? B matrix is actually 5, 12, minus 3. That is a column matrix. Please understand that B has only one column. So B has only one column. So what is the column? 5, first row, second row, 12, third row, minus 3. 5, 12, minus 3. That is the column vector. I hope this is clear. How can you find out the solution? A inverse into B will give you the solution. Okay. Now, so first you need to enter the matrix A, input enter the A matrix, B, input enter the B matrix. So you need to input two matrices, A matrix and B matrix. Okay. Now you find out the size of A. What is the size of A? M row and N column. M rows and N column. Size means it will return the rows and columns. So this format will return m rows and n column. I hope this is clear. Now you need to understand two things before solving this matrix equation. Okay. So for a system of linear equations, if rank of A column B is not equal to rank of A, what is rank of A? This is the rank. R stands for rank of a matrix. R stands for rank of a matrix. So if R of AB, what is AB? AB is A, then you are writing A first, then you are writing the B. That means you are combining two matrices, A and B, and you are producing it as a one matrix. Okay, you are combining two matrix and you are showing it as a single matrix. So A, B means after A you are writing B. Okay, it is a concatenated matrix. After A you are writing B. So rank of AB, okay, that is an augmented matrix. You call it as an augmented matrix, AB. That is an augmented matrix. So rank of this augmented matrix is not equal to rank of A. If that condition is true, if rank of the augmented matrix is not equal to the rank of A, then the system has no solution. That means the system is inconsistent. It has no solution at all. You have studied all these things in your mathematics class. If the rank of the augmented matrix is equal to rank of A, equal to number of unknowns, then the system has unique solution. That solution you need to find out. Okay, if rank of augmented matrix is equal to rank of A and less than the number of unknowns, then the system has infinite number of solutions. Once again, I repeat, if rank of the augmented matrix AB is not equal to rank of A, the system has no solution. That means inconsistent. If rank of A, B, the augmented matrix is equal to rank of A, equal to number of unknowns, the system has a unique solution. Then if rank of A, B is equal to rank of A is less than the number of unknowns, the system has infinite number of solutions. Clear? Now I will show you another thing. This is homogeneous linear equation. What do you mean by homogeneous linear equation? You are representing it as Ax is equal to B. In place of B, you have an O. This O means it's actually null or 0. Okay, Ax is equal to 0 or O representation. That means Ax is equal to B is your matrix equation. Ax is equal to B. That was your original equation. Ax is equal to B. So here you are writing it's a homogeneous linear equation. Ax is equal to O or 0. This means a null. Okay, so Ax is equal to 0 form or O form. That means x is equal to 0 is always a solution for homogeneous system of linear equation. So here x equal to 0 is always a solution. Please understand that is called a null solution or trivial solution, which is called a null solution or trivial solution. X is equal to 0 is always a solution. If there are three unknowns, x, y, and z, what will be the resulting solution? X equal to 0, y equal to 0, z equal to 0. So if there are three unknowns, all the three unknowns will be having 0 value as a solution. Okay, which is called the null solution or trivial solution. This is always there. So this is always a solution of Ax is equal to 0 or homogeneous linear equation. If rank of A is equal to number of unknowns, then the system has only the trivial solution. Trivial solution means null solution. So system has only the null solution or trivial solution when if R of A, rank of A equal to number of unknowns. Okay, if suppose rank of A is less than the number of unknowns, then the system has infinite number of solutions. So please understand the difference. If the rank of A is equal to the number of unknowns, the system has only the trivial solution or the null solution. That means x equal to 0, y equal to 0, z equal to 0. If the rank of A is less than the number of unknowns, the system has infinite number of solutions. This is the case of homogeneous linear equation. So while you write the program in a generalized form, you need to incorporate this also. I hope this is clear. Okay, now we will understand what is the program. Okay, so this matrix solution, okay, A equal to input, enter the matrix, A matrix and B matrix you have entered. So first you enter the A matrix, second you have entering the B matrix. Okay, now you are finding the size, M row, N column, that is the size of the matrix. Okay, now C is equal to AB, and what is this C? C is the augmented matrix. You are augmenting A, after you first write A, then after you write B. So this C is equal to AB, after A, then comes B. So this is the clubbed matrix or augmented matrix. C is equal to AB. I hope this is clear. Now you find out, you check the conditions. First condition is that, what is the first condition? The first condition is if rank of A is not equal to rank of A. So rank of augmented matrix is not equal to rank of A. Rank of augmented matrix is equal to rank of A. So we will first check this condition. If rank of A, rank of augmented matrix, okay, is equal to rank of A, equal to number of unknowns. So if rank of A, how can you find out the rank of a matrix? You can use the built-in function rank, R-A-N-K, rank. Okay, so if rank of A, you can find the built-in function rank. Rank of A equal to rank of C. What is C? C is the augmented matrix. So rank of augmented matrix is equal to rank of A matrix. What is C? C is the augmented matrix. So if rank of C is equal to rank of A, then you need to, inside that if statement, you need to again check whether the rank of A equal to number of unknowns. What is the number of unknowns? The number of unknowns will be the number of columns, isn't it? What is N? N is the number of columns. N is the number of columns of A, isn't it? Size of A. N is the number of columns of matrix A. So actually N is the number of columns and here N is the number of unknowns. So because since number of columns is equal to number of unknowns, isn't it? Number of columns of a matrix will be equal to the number of unknowns. Okay, so if rank of A equal to rank of C and if rank of A equal to number of unknowns, then you can say that display the system has unique solution. You can display that the system has unique solution. Now you can find out the solution. How can you find out the solution? The solution, let me represent it as Z1. Z1, how can you find out? A inverse into B, that is solution. As I've already mentioned, what is the solution? Solution is A inverse into B is the solution. Okay, so how can you find out the solution? Inverse of A. A inverse into B will be the solution. So solution I have assigned it to a variable Z1. Else. What is else? Else means rank of A not equal to N. That means else, again I am providing if the condition is rank of A is less than N. That means here if rank of A equal to N, and again I am providing else condition. That means else if rank of A is less than N. That means rank of A is less than the number of unknowns. What happens? If the rank of A is less than the number of unknowns, what happens? Is less than number of unknowns, then the system has infinite number of solutions. So here the system has infinite number of solutions. System has infinite number of solutions. I hope this is clear. Now you are ending this if statement. This is if statement you have ended. Now you have ended the above if also. Okay. Next, else part. What is this else part? Else part mean if rank of A not equal to rank of the augmented matrix. That means if the rank of A not equal to rank of augmented matrix. So how can I else part? What is inside the else part? If rank of A not equal to rank of the augmented matrix, the system has no solution. So display the system has no solution. I hope this is clear. Now you end the last if statement. Okay. Okay. Now, one more condition you need to check. You just need to display whether if it is a homogeneous system. Okay, if it is a homogeneous system, I need to check whether B equal to 0 or not. If it is a homogeneous system means Ax is equal to O. So null solution will be always there, isn't it? So I can check whether B equal to 0. B matrix. What is B matrix? Ax is equal to B. Ax is equal to B. So B means if B equal to 0 means all the elements inside B are 0. B is a matrix or column vector, isn't it? So if all the elements of the column vector B are 0, then I know that this is a homogeneous system of equation. Ax is equal to O, isn't it? Or Ax is equal to 0 because B is 0. Okay, now display. It has a trivial solution. You know that if it is a homogeneous one, it has a trivial solution. So the trivial solution is what? The solution is Z1 equal to 0. You can put an end here. So let me reduce the font size and show you the entire program. This is the entire program. You can see if rank of A equal to rank of C, and inside that I am displaying whether, checking whether rank of A equal to number of unknowns. If it is correct, I am checking it has a unique solution, so find out the solution. Else, that means if rank of A is less than the number of unknowns, then I am displaying the system as infinite number of solution. Then otherwise, if rank of A not equal to rank of C, then display the system has no solution. So this is one if else statement. This is one if else. This is if else statement. Okay, this is another if else. So it's an ST. Inside one if there is another if else. Okay, this is another if else. I hope this is clear. And the last, you just check whether it is a homogeneous. If it is homogeneous, the trivial solution it will display. Okay, so there will always be the trivial solution. That is the condition. Okay, I hope this is clear. And now we will execute this. So first you need to enter the A matrix. In our example, what is our example? This is our example. So what is the A matrix? 2, -1, 3. That will be our A matrix. So I will enter the A matrix. 2, -1, -1, 3. That is my A matrix. What will be by second row? 4, 0, 5. 4, 0, 5. That is by second row. Then what is my third row? 1, 1, 2. That is my third row. 1, 1, 2. So I need to enter the B matrix. B matrix is 5, 12, -3. 5, 12, -3. So 5, it's a column vector. Please understand that B matrix is a column vector. It has only one column. So 5, 12, then what? 5, 12, and -3. So -3. It's a column vector 5, 12, and -3. I hope this is clear. 5 is the first row, second row is 12, third row is -3. So only one column. Okay. So you enter the B matrix like this, not as an array. Like this. Separate the rows using a semicolon. Please don't forget that. Okay. Please enter the B matrix like this, separated by a semicolon, because you are entering a column vector. Okay. So A and B you have entered. Now what is the answer is the system has a unique solution here. And what is the solution? This is X value, this is Y value, this is Z value. So this is also a column vector. Okay, so the solution, the system has unique solution. What is the solution? X, Y, and Z value. I hope this is clear. You can check with more examples. Okay, so that's all about this matrix and matrix solution of system of linear equations. So we have seen this also. Okay. Now I think it is clear. So you do have two programs, and one more thing I need to explain to you. You can find the A inverse as, sorry, not A inverse. You can find the matrix solution of a system of linear equations by using another method, linsolve. This is an inbuilt function in MATLAB, linsolve of AB, where A is a matrix. Okay, this is A is a matrix. Okay, B is another matrix. B is a column vector. 5, 12, and this is our previous example itself. A is our square matrix and B is a column vector. 5, 12, and minus 3. So, linsolve of A comma B. If you type like this, you will get the solution Z. So, this is same as finding inverse of A into B. Same. These two are same. Inverse of A into B is also your solution. Linsolve is also your solution. So, you can just type linsolve of A comma B. Okay. Same as inverse of A into B. Which is inverse of A, you can find out as A raised to minus 1. Because A inverse is A raised to minus 1 is same as A inverse. So you can type A raised to minus 1 is same as A inverse into B. This is same as A inverse, as I've already told you, A inverse is same as A backslash B, isn't it? A inverse into B, which is same as inverse of A into B, which is same as A backslash B. What is A backslash B? We have already seen this. See here. A backslash B is inverse of A into B. Okay. So A backslash B is inverse of A into B. So these four are same. Will give you the same. Let me check this. So I'm going to run this. Yes, I have run. Just type set. You go to your set. You go to your set 10 minus 1.8 minus 5.6. This is your solution. Now you check set 1. Check set 1. Set 1 is also same. You check set 2. Set 2. Set 2 is also same. You check set 3. Set 3. Set 3 is also same. I hope this is clear. Okay. Thank you.